Hello dear student, in this video we will see benzoin condensation reaction. We will see statement reaction and with its mechanism. So like the video and subscribe the channel for more updates. That is benzoin condensation. The name itself indicate benzoin. So benzoin, it means at the end of the reaction we get a benzoin, and it is a condensate product. It is condensate product of 2 moles of benzaldehyde, and they forms a benzene. It is also called generally alpha hydroxy ketones because the structure of an benzoin, it is an alpha hydroxy ketone. Let us see the reaction for benzoin condensation. In this reaction, 2 moles of benzaldehyde react. So I will write the structure of benzaldehyde. These are the 2 moles of benzaldehyde that will react. And it is in the presence of potassium cyanide or sodium cyanide. Cyanide plays an important role and it acts as a catalyst. We will see in the mechanism. Plus it requires aqueous alcohol and it will give the product that is benzoin. This is benzaldehyde and there are 2 moles of benzaldehyde and we got benzoin, and it is also called alpha hydroxy ketone because if we see the position of an hydroxy, it is at an alpha position, as this is a ketone group and hydroxy group, it is at an alpha position. So alpha hydroxy ketones. Now we'll see the mechanism of the reaction. In mechanism, first step is nucleophilic addition of cyanide with benzaldehyde to form carbanion. See, all the reactions, whatever we are seeing in this carbonyl compounds, all they are nucleophilic addition reactions. So in the first step, benzaldehyde. So I will draw the structures of benzaldehyde. It is containing an electron deficient carbon and electron rich oxygen, as it is having a pi bond in between. So this pi bond it will break and the cyanide it will attack. So sodium cyanide or potassium cyanide. See, further this bond between potassium and cyanide, it will break in a such way that the electrons will be shifted on the cyanide and it will gain a negative charge. Once it gains the negative charge, and potassium, it is actually a metal, so it will have a positive charge. So this cyanide, it is now a nucleophile which is acting a nucleophile. It will attack an electron deficient center. So it will attack an electron deficient center and it will break the pi bond between carbon and oxygen and it will transfer the electron towards the oxygen. Here there are 2 lone pair of electrons on oxygen. Now as the lone pair of electron it has been shifted on oxygen, now it becomes 3 lone pair of electrons. Now further the structure, it forms an carbanion by shifting of a proton on oxygen. this oxygen is now become negatively charged, and it is having a cyanide and it is having a proton. So the lone pair of electron on oxygen, they are 3 as one bond, and it is also having a negative charge. Now there will be a proton shift. So proton shift means the electron pair, it will attack or it will abstract the proton, and this proton, they will leave the electrons on a carbon. So this is a reversible step. Now there are only 2 lone pair of electrons. One has been utilized for bond formation with an hydrogen, and this carbon, it will be negatively charged and it will have a cyanide. So this has become an carbanion. So this compound, it is an carbanion, and here we started with an benzaldehyde. And this, it is an cyano group, or you can say it is a nucleophile. So nucleophile has been added and it has formed an carbanion. Now in the second step, this carbanion, it will react with the second mole of benzaldehyde. So let us draw the structures. Here there is an electron deficient carbon in the second benzaldehyde, and here it is a carbon electron rich carbon. So it will attack on benzaldehyde, second mole of benzaldehyde, and once it attacks the electron deficient center, the pi bond between carbon and oxygen will break and the electrons will be shifted further. This nitrogen, it is having one lone pair. Now further, it will condensate. Now it has formed an condensation of these two products, and further condensation, after the condensation, there will be an proton shift. Oxygen, it is having this oxygen, it is having now 3 lone pair of electrons, and further there will be a proton shift. So proton shift means hydrogen from this oxygen, it will be shifted on the next oxygen. So here the one of the lone pair of electron, it will be donated toward the proton for the bond formation, and the bond between this carbon, oxygen and hydrogen, not carbon, oxygen and hydrogen, it will break in a such way that electrons will be transferred on an oxygen. Here it is having only 2 lone pair of electrons, further it will have 6 lone pair of electrons, and it is the reason behind this, it is the stability reasons. So these are interconvertible structures. This oxygen will have a negative charge, and now there are two lone pair of electron on this oxygen. Here it was 6 when it utilized for a bond formation with a hydrogen, as proton has been shifted. So this step, it is a proton shift. Now in the further step, step 3, removal of cyanide group and forming a benzoin. So whatever the product we have got till yet in the second step, this removal of cyanide group, it is due to that electron pair, it has been shifted on oxygen and it forms a pi bond, and the sigma bond between these two, it breaks and it carry away electron with itself, and this carbon, it becomes an electron deficient, but it has been satisfied by incoming electron pair from an oxygen. Now further, the cyanide, it has been removed. The cyanide, it will be removed, and we will get the product that is benzoin. It is also alpha hydroxy ketone. The name of this compound, it is benzoin. That is why the reason it is said to be an benzoin condensation. 2 moles of benzaldehyde, they react in the presence of an potassium cyanide or sodium cyanide with aqueous alcoholic medium, and we get a benzoin, and it is generally called alpha hydroxy ketone. Thank you for watching the video. If you are having any doubts, you can comment me in the comment box section. I will surely answer it.